The last thing we need to do to finish this part is drill the holes shown in the file. For this, we're going to take off our covers so the holes are open, and we need to define the entities we want to use. Based on the size of these holes, or from our print, we know that these holes are reamed holes and these 4 are tapped holes. We are going to set them up accordingly. These are a metric ream. We don't want to control our start position, and we want to filter by diameter. By turning these selections on, it allows us to grab any hole, window the entire job, and it will find all entities that are the same diameter. We can check on blind or through depending on what type of hole we want. In this case, we want blind. We can now execute, and you will notice it has now created 2 entities on its own layer. We can repeat this process for the tapped holes. When you execute, you now get all of your entities have now been created. Once your entities have been created, the next step is to use Create All Processes to create your programs. By windowing all of the entities you have created and hitting Execute, CAM Tool will automatically generate all of your tap drill, reamer drill, ream, and tap programs and add them to your list. Once you have done this, you can hit play, and you will notice your program's calculated. There's a center drill, your tap drill, your reamer drill, your reamer, and your tap. Once the programs are calculated, we see that we have a warning on our reamer program. When we right-click and go to the Show Optimization Error, we see it says Tool Bottom Interference. This means the bottom of the reamer is interfering with stock at the bottom of the hole. I'm going to open up the program and see what is causing this. In this case here, the tip of the reamer is stopping 1 millimeter from the bottom of the hole. I'm going to change this to 2 millimeters. I could also change my drill to drill deeper in order to solve this problem. While I'm in here, I will describe some of the features we can use to control our drill programs. The start compensation is the distance it's going to start above the hole. Cutting depth controls how far you're drilling into the steel. This can either be controlled by using the hole entity that you've created using the geometry you have available, or just simply entering a value. In this case, we're using the hole entity. With that, if it's blind hole or through hole, you can have it go either the tip or the shoulder and giving it a compensating amount to go either short of the bottom of the hole, or in the through case, it would be past the bottom of the hole. This is where you pick your CAN cycle code, whether it be G81, G83, etc., depending on what type of CAN cycle you are using. Your cutting volume are your peck depths, and this is the dwell if you want to add a dwell into your program. This is your tooling page, and that's the basics of our drilling programs. We now hit OK, recalculate these programs, and you'll now see we don't have any errors, and we are ready to post this file. One thing to be noted is that all of these drill cycles are able to be customized exactly the way you want them to run. If you're using carbide drills with faster feeds and speeds and don't want a center drill, that is entirely possible. We will get into editing the drilling template database at a later video.